Lesson 2.6 is on inequalities. First thing we're going to talk about is interval notation. You should be somewhat already familiar with inequality notation. Take a look at this one right here. When we have two values a and b and x is in between them, if you looked at a number line, you'd have open circles on both a and b. This is how we'd write it in interval notation. I know that the Newland and Spicer students have seen this before in pre-calc and in Algebra 2. I'm not sure about the Lester Prairie students. When we have an inequality that has the equal to part, then we'd have closed circles on the number line like this, and then our interval notation would have brackets instead of parentheses. So the brackets indicate closed circles on a number line, the parentheses indicate open circles. Also, always remember in interval notation we write smallest to biggest, so a is always smaller than b. The next one, this would have a bracket on the a, a parenthesis on the b, which simply just means we'd have a closed circle on a and an open circle on b. Continuing down, if we had something like this, that would mean a closed circle on b and an open circle on a. Let's just get rid of this. Moving down, now those are all bounded intervals, meaning there's a highest point, there's a lowest point, but now sometimes we have unbounded intervals. For instance, if x is greater than a on a number line, that would have an open circle and shading forever to the right. And this is how we would say the interval notation. We'd say a to infinity. Okay? Always put a parenthesis on an infinity sign. In this case, since it's an open circle, we'd have a parenthesis on the a. This would be another unbounded interval. The only difference here is we'd have a closed circle on a shading forever to the right, and the interval notation would have a bracket on the a to infinity. Some other unbounded intervals would be less than b. That's an open circle on b, shading forever to the left. Now our interval would have to have a negative infinity to b with a parenthesis. And the next one, less than or equal to b, closed circle on b, shading forever to the left, would have to have a bracket on the b with a negative infinity in front of it. So that's interval notation. Lester Prairie students, I hope that you've seen this before. I know the Newland and Spicer students have. We're going to use that to solve inequalities. We'll start off with some basic linear inequalities. You know the rules of algebra. Anything you do to the left, you got to do to the right. Now the next step would be to divide by a -3. Do you guys remember from Algebra 1 that there's a rule with inequalities? Anytime you multiply or divide by a negative, you got to switch your symbol. There we go. So this would be the inequality answer, but you're going to see interval answers in the back of the book. So for this particular problem, you're going to see a -7/3 to infinity, because this would have a number line. And if we located -7/3, which would be someplace between -2 and -3, that would have an open circle and would shade forever to the right since it's greater than. Okay? Another simple linear inequality. This time we got to combine like terms. I want to move the 2x to the left by subtracting. Move the -3 to the right by adding it. Divide by 2. We do not switch the symbol. We get x less than 4. This is an unbounded interval. This would be the inequality answer, but the answer you're going to see in the back of the book is going to look like this. -infinity to 4. Again, always write smaller values on the left, bigger values on the right, and pay attention to whether you should use brackets or parentheses. The next one is called a compound inequality. There's three sides. There's a left, a middle, and a right. So kind of like the same rules of algebra, anything you do to the middle, you better do to the right, and you better do to the left. That would give us a -2 is less than 2x less than 6. Divide everything by 2. Gives us -1 is less than x less than 3. So this is an unbounded interval. This would be the inequality answer. And the answer you're going to see in the back of the book is going to be something like this, from -1 to 3, parentheses on both of those because it doesn't have the equal to part. Another compound inequality here. Again, there's a left side, a middle, and a right. So if you multiply each side by 2, we'd have a negative 10 is less than or equal to 4 minus 3x less than 2. Now we'd subtract 4 to each side, giving us a negative 14 less than or equal to negative 3x less than negative 2. And now we're dividing by negative 3, which means we're going to have to switch that symbol. And so this is going to end up becoming 14 thirds, a negative divided by a negative. Switch the symbol. We just have an x now in the middle. Switch that symbol, and we get a positive 2 thirds. This would be the inequality answer. Excuse me. And the bounded interval answer would be numbers bigger than 2 thirds, but smaller than 14 thirds, and I would need to have a bracket on the 14 thirds because it has the equal to part in the inequality. Next one is a rational inequality. Now if you think about this problem, just take the left-hand side for instance, okay? The top is always a positive 1, right? Well, the bottom is an expression. If the bottom expression is equal to a positive, then this whole fraction is going to be greater than 0. So what we want to do is we want to find out when is x minus 2, when is it greater than 0? And so this is the inequality we're going to solve. Obviously, move the negative 2 over by adding. X value is greater than 2 is going to make this fraction have a positive value in the denominator, making the whole fraction positive greater than 0. So this would be the inequality answer, and the interval answer you'll see in the back of the book will be something like that. From 2 to infinity, you need to have a parenthesis on the 2. We'll also have some absolute value inequalities. Similar to solving absolute value equations, solving this absolute value inequality, we write an inequality out like this without the absolute values. We write another one. We switch the symbol, and we switch the 0.5 to a negative 0.5. And now solving both of these would give us our solution. We get x values less than 3.5. We get x values greater than 2.5. So that's the inequality answer, and the interval answer would be from 2.5 to 3.5, parentheses on both of those. This would be a bounded answer. It doesn't go forever to the right or forever to the left. Another absolute value inequality. 2x plus 3 has to be greater than 9, and 2x plus 3 has to be less than negative 9. So to solve these, using our rules of algebra, we find that x has to be greater than 3. We'd also find that x has to be less than negative 6. And so the unbounded answer now, think about x values less than negative 6. I'm going to write that like this, negative infinity to negative 6. Then I'll use a union symbol, and I'll write another set for x values greater than 3, and I'll say 3 to infinity. So this one has two regions that make up all the solutions. This is unbounded. It goes anything less than negative 6 and anything greater than positive 3. Here's the homework that you'll be working on tomorrow in class. This will be collected Thursday. Hope things are going well. We'll see you guys in a few days.